All right, and my new favorite, policy violations and security violations. So these are completely 100% configurable by you. And what that means is, we start you out with some examples, but this is an example of something that one of our developers noticed. When you look at let's say we look at all GCC invocations. So GCC just told me there's like, the 975 of them, right? If you look at them, notice how they all call WALL flags. So that says turn on all warnings. So you might look at this and go, hey, you know what? We have a policy that says that all compilations must turn on warnings. But eyeballing this and going, hey, do all the GCC commands actually have this? That's a little bit tricky, right? So instead we build a rule that says any command that is, and then you can fill in regular expression for the command, in this case I said GCC, assert that it has the option WALL, and then I got to fill in the text that would be here. And the text I put in is, GCC/G++ is missing -wall option. So that's my rule. That's violated. I probably could have made this, a little bit more friendly or verbose, but I was worried how much of this would be visible. So you can see there's actually two invocations of GCC here and here. Actually, they're both in the exact same place, all from the same makefile, where the wall option was not used. Interesting. Actually, it looks like GCC maybe is being used as a linker rather than as a compiler. So now I'm be like, well, maybe my rule needs to be fine-tuned because, well, maybe it's only GCC that has source file anywhere on the compile line, and I can match source file by using regular expression, saying, if there's a .c or a .ctp or something like that. Only then should you enforce that there should be -wall. Now, security violations are, and by the way, there's a lot of different things that can be configured with policy checkers. For example, you can have a policy that no single command can take more than 10 minutes, in which case the ones that take more than 10 minutes will be flagged in this tab. So essentially, just a way of verifying, a way of showing you what is going on in your build, calling it out as, hey, this thing is not quite complying with what you think should be, best practice. Now, security violations are just policy violations that you put in a different section of the config file. So they're structured the same way. For example, you might say certain commands must not use relative paths, or certain commands must not use absolute paths, may only use relative paths, or, certain files, certain files should not be passed to certain commands, or certain commands may not be called from certain directories, right? It's whatever you can think of and whatever reflects the type of things that you want to enforce. Security violations. So, for example, we might say that, hey, there are certain flags, for example, optimization flags, that we will not run in production when we're producing a production build because we have some code that clears away passwords after they're referenced, and optimization optimizes away this code, producing less secure binaries. So you instill that rule and you tell everybody, hey, everybody, make sure that you don't use this flag with your compilations. And people go, yeah, somebody else will fix it, right? How do you know that whoever fixed them got them all? And so here, you have this situation where you can quickly go through and find all the places where the flag that's forbidden is still in use. So this just kind of shows you a couple of examples. There's actually pretty much an infinite number of things you could enforce because, your rules might be completely different than somebody else's rules. And therefore, we give you the ability to set up these rules yourselves. So, there you go. We got some time left for questions. So I am going to open the little question tab now. And I'm going to see what questions people had. And so now if you typed in a question while I was chatting, I will Let's scroll back and find it. If you think of one, please go ahead and type one, and I will try to address them. Okay, so somebody would like to know what the platforms or what different processes this tool works with. Right now, the Build Analyzer can monitor builds on Unix systems, Linux, 52, 64-bit, Solaris. The Windows version is coming next quarter. And as you can see, the GUI can run on Windows even right now, or on Linux, I think Solaris. Alrighty. And then, yeah, as far as the actual processes that we would monitor, right now we can monitor anything that runs any kind of scripts, any scripting language, any kind of make, gmake, omake, mmake, etc. The version that's coming out next, I believe, will be able to follow AMP. So right now, this probably will work for just about anybody who's doing C++ development. For Java, it works right now if you call the Java compiler directly. And the future version, it will work even if you call AMP and don't spawn off any tasks. We will interject ourselves into the process and monitor that as well. Okay, so yeah, parallel builds, there's a great question. Does the tool support parallel builds using make-j? Yes, it does. Essentially, what happens is when you run your make command, it spawns off several processes, and because build, which is watching, will just spawn one process per process that it's observing. So it will collect that information, and then we'll be able to aggregate it back into this database. One actually interesting thing that some of our customers have done is rerun the same build both in parallel mode and in serial mode and compare and, kind of try to gain some insight into whether what's going on is what they expected or not. There's I see a question about costs and license. I know nothing of such things. I am a person who's technical, and I'm sure that your sales rep, who I wouldn't know who it is because there's one for a different region, but if you email sales@coverity.com, I'm sure somebody will send you information about pricing or free trial or whatever else activity. Yeah, actually the thing is, this demo I tried to go, I try to cover most of the functionality. I think it's probably much more interesting if you're looking at this in the context of your own build which you understand and you know. One of the interesting experiences I had is the first half a dozen customers that I worked with, the first time they looked at this output, all of them saw something about which they said, well, that's not possible, your tool is wrong here, we don't do that. And in every case, we dug into it, and it turned out that they did do it, but they didn't realize they were doing it. Either somebody made a change that they weren't supposed to, or it was some artifact left over from a legacy system. In one case, it was spawning off a shell script as part of a compilation command just to fill in some compilation options, which was a mistake, and they didn't realize that that